Okay, section 3.4, part 2 video. In this video, we're going to look at how our equations compare to now parallel and perpendicular lines. So we're going to look at what the equations of parallel lines look like and perpendicular lines. First, we need to talk about what parallel means. Okay, parallel lines never intersect. They run next to each other. They run forever and forever and never intersect. Perpendicular lines, on the other hand, intersect at 90 degrees. They make a nice right angle. Okay, so let's go ahead and first let's look at some parallel lines. Okay, so I have some points here on my parallel lines. Okay, I have these 2 points I'm going to connect to make a line. So there's my purple line. We'll call that line 1. Okay, and the ordered pair on that is the point 3, 1, and the point 0, 2. Okay, and now let's go ahead and let's do the red line. Here, the red one. We'll call that line 2, and the ordered pair on that is the point 1, 0, and the point -2, 1. Okay, let's go ahead and let's compare these lines. Okay, what I mean by compare is let's compare for one their slopes. That's a numerical value we have here. And if we look, the steepness of these 2 lines is the same. It appears the same. That's what it looks like. Let's go ahead and let's see if that's true. So let's find the slope of line 1. So the slope is equal to, let's see, y2 minus y1 over x2 minus x1. So let's see, let's have this be point 1, this be point 2. y2, which is 1, minus y1, which is 2, x2, which is 3, minus y1 is 0. 1 minus 2 is -1 over 3. So my slope for the purple line, my line 1, is -1/3. Okay, now let's evaluate the slope of my red line, line 2. Okay, let's go ahead and let's have this be line 1, this be line 2. So let's take y2, which is 0, subtract y1, which is 1, x2, sorry, that would be plus 2. So we get -1/3. Okay, if you notice, these 2 slopes are the same. And that will hold true for any parallel lines. So parallel lines have the same slope. So here, any line that has a slope of -1/3 will be parallel to the purple line and the red line. So any line that has a slope of -1/3, so any of these lines that have a slope of -1/3 will be parallel to these 2. So parallel lines have the same slope. Useful information there. Okay. Perpendicular lines, on the other hand, okay, let's go ahead and let's sketch some perpendicular lines. Okay, I'm going to connect these 2 points, 1, 2, 3, 4. So this is the point 4, 2. And the point 3, -1. I'm going to connect those 2 points. We get a line like this. There's my green one. We'll call that line 3. Okay. And then let's connect these 2 points. This is the point -2, 1. This is the point 1, 0. Now these 2 lines intersect at a 90-degree angle. Okay, see? 90 degrees. So they are in fact perpendicular. Now let's go ahead and let's evaluate the slopes on these. For one, I can tell the slopes are definitely not the same. This slope here is going to be negative, it's going down. This slope here is going to be positive. And this is way steeper than this one. So this slope is probably going to be a smaller negative number. This one's going to be a much larger positive number. Let's go ahead and let's find the slope of the green line. Again, we're using m equals y2 minus y1 x2 minus x1. So let's see, let's have that be 0.1, 0.2. So let's see, I'm going to take my y2, which is negative 1, minus my y1, which is 2, x2, which is 3, and 4. Negative 1 minus 2 is negative 3. 3 minus 4 is negative 1. Negative 3 divided by negative 1 is 3. So the green has a slope of 3. Now let's look at the blue slope. Well, okay, I just noticed something. This blue line, doesn't it go through the same points as this red line? Negative 2, 1, 2, 1. So it's going to have the same slope. So it's going to have the same slope as this red line up here. So it's going to have, I don't have to reinvent the wheel. Let's use the slope from before. Negative 1/3. Okay, now let's go ahead and let's compare these two slopes. Okay, obviously they are not the same. Up here, for parallel, they were equal. Down here, obviously they're not. Let's go ahead and let's write this as a fraction. This is 3 over 1. This is 1 over 3. This is positive. This is negative. So it looks like there are different signs, negative, positive, and they're the flip. And the word for that is reciprocal. So perpendicular lines have slopes that are negative reciprocals. Again, that bit of information is important. Perpendicular lines have slopes that are negative reciprocals. They're basically the opposite sign of each other and flip-flopped. The rise and the run are flipped. Let's go ahead and let's use these two bits of information. Okay, for my examples, I want to find a line parallel to this line through the point P41. So I want it parallel to this line here. Parallel, again, I want it to have the same slope as this line here. So first things first, I want to find the slope of this. To find the slope, I'm going to solve for y. Okay, so if I solve this baby for y, so let's see, 2x plus 5y minus 2x equals negative 10 minus 2x. 5y equals, let's rewrite it, negative 2x minus 10. Divide both sides by 5. So then y equals, if I divide both of these by 5, negative 2/5 x minus 2. So I now know the slope of this line here. The slope is negative 2/5. So the line that would be parallel to it would also have a slope of negative 2/5. So I want a line with a slope of negative 2/5 that goes through this point right here for 1. Well, I know the slope. I know a point. I'm going to use point slope form. Y minus y1 equals mx minus x1. So it'd be y minus my y1 is 1 equals m negative 2/5. X minus x1 is 4. Okay, so now I just need to get it into standard form. Okay, so we distribute. Plus 8/5. I'm going to multiply everything by 5. Let's bring it over here. Multiply everything by 5. So let's see, that would give me 5y minus 5 equals negative 2x plus 8. I'm going to add my 2x to the other side. And then I'm going to add my 5 over here, which gives me 8 plus 5 is 13. So there is my equation in standard form. So this line is parallel to this one, but it goes through the point 4, 1. Okay. Okay, so any questions on that one? We could sketch it over here to double check. Okay, this line, we'll call this the purple line. Okay, so this is the purple line. Goes through, well here's the equation. It has a y-intercept of -2, slope of -2/5. So down 2, run a 5. 1, 2, 3, 4, 5. So it's going to look like this. Okay. And then this one is going to go through the point 4, 1. So 1, 2, 3, 4, 1. But also have a slope of -2/5. Down 2, run 1, 2, 3, 4, 5. So this line is going to look like this. Parallel. Okay. Number 2, find a line perpendicular to 2x plus 5y minus 10. So I want it perpendicular to this line right here. Again, perpendicular is, I want negative reciprocal slope, negative reciprocal slope through the point 4, 1. Well, if you notice, this line is the same as the one up here. And we already know the slope of this line. The slope of this line is -2/5. We found that out up here. So let's go ahead and let's use it. I know the slope of this line is -2/5. So the slope of a perpendicular line is going to be the negative, so it would be positive 5/2. And it's again going through the point 4, 1. The slope of this line is -2/5, so the slope of the perpendicular one would be positive 5/2. So then again, we're going to use y minus y1 equals mx minus x1. So y minus 1 equals 5/2 x minus 4. Now do some distributing. Let's see, y minus 1 equals 5/2 x minus 5/2 times 4 is 10. Multiply everything by 2. 2y minus 2 equals 5x minus 20. Okay, I'm going to subtract my 5x to the other side. Add my 2 to the other side, so I give me minus 18. But my leading coefficient here is negative, so I'm going to multiply both sides by -1. So we'd have 5x minus 2y equals 18. So now this is the equation of the line that's perpendicular to this one that goes through this point 4, 1. Okay. Now you have 2 your turn problems. Go ahead and attempt those. They are very, very similar to the examples that I did. Write down any questions that you have and come to class ready to discuss.